Hey guys, and welcome back to a new video. In this video I will talk about dependency scopes using Dagger-Hilt. Recently I actually posted a short on YouTube in which I told you that you should always use the minimum required scope when using Dagger-Hilt. And when reading through the comments, I felt like for many people that wasn't fully clear why you should do that and what that actually means. So here is a more detailed video in which I will actually tell you why you should always use that minimum required scope and not make all your dependencies a singleton like I see so often in people's repositories. So that won't be a typical coding tutorial here. You don't need to do anything. You can just lean back and learn. I will just show you some different things here in my sample project. Starting in this app module, that's a very common thing we have on Android. Just an application module, singleton component, and the dependencies we provide in that module will also be singletons. So that's actually the scope. That means these dependencies will live as long as the application does, and there will only be a single instance of that throughout the whole application's lifetime. And if we take a look in here in that session timer class that I provide, then that is just a very, very basic sample timer here. We have an isRunning boolean in the session time variable, and then a start timer function in which we simply increase that session time once a second. And we also can stop this timer here, where we just set isRunning to false, so we break out of this loop here. Nothing very special, just for demonstration here. And that in and of itself is a good thing to do, to actually put this logic into its own class. You can call it session timer. So you just follow that single responsibility principle, that this class has the clear responsibility of actually managing this timer logic. However, what's now the issue that we make this a singleton? The issue is that making it a singleton, on the one hand, there are actually two issues. On the one hand, that means that this instance, this session timer instance here, will occupy memory as long as your application lives. So let's say you are working on a video calling app. That is actually the example I want to use here. And for that very simple one, a simple video calling app, you actually have a login screen, you have a video calling screen, and you might have like a call info screen where you just get some extra information about the call. And you need the session timer on the video call screen and on the call info screen, but not really on the login screen, because the session time isn't really going to be displayed there. However, if you make this a singleton, this will also occupy memory on the login screen. But wouldn't it just be better if we could only keep this instance alive if the user is actually on either the video calling screen in an active video call or on the call info screen, where they would also probably be active in a call? For sure, that would be better. That is one issue, but I think the second issue, and the even bigger issue that many people don't even think about, is that the current way of doing that, of making this a singleton, can very easily lead to bugs. Because what we essentially have here is a stateful singleton. Stateful singleton simply means here that we have a singleton with state, so with a value that can change over time, which is this session time, and this isRunning would actually also be considered state. And you probably already have heard that you should not use global variables, or you should be careful with global variables at least, because they can quickly lead to bugs. Having stateful singletons is essentially using a global variable, because these variables live as long as your application does. So what specifically can lead to these deadly bugs that I talked about here? For that, let's actually take a look at our different screens. I prepared a navigation graph here just for pure visualization. So we have our login screen, we have our video call screen, and our call info screen. So here our application will obviously start, the user will log in, and then they can join a call and actually get information about that call. In these two screens, we actually need our session timer, because here the video call is actually going on. However, our singleton, our stateful singleton, is actually living as long as all of these screens. So it will also be active in the login fragment. So what will happen here is the user will go to the login fragment or login screen. Doesn't matter if you use Compose or XML. They will log in, they will get to the video call fragment where they can actually join a call, and here we will actually also call the start timer function when they actually start the call, obviously, because then we want to track the time during the call. However, then if they actually leave the call, we would obviously call the stop timer function, which would break out of this loop. They would go to maybe some kind of other screen and eventually get back to the login fragment where they can also log in for another call. Or you could also think of some kind of invitation screen or so where you just need to enter some kind of code to join a call. So that is what would happen. The thing is, if they already joined a call and then left the call and then joined another call, what would happen is, in this case, the timer would simply start from the time where they left the first call. Because as you noticed, I forgot to actually reset the timer here in stop timer. What we simply do is we set is running to false, which will stop the timer, of course, but that doesn't reset the session time. The session time will still be at the value where we actually left the first call. So that means if the first call was for 60 seconds, then we left the call, joined the next call, then the session time would start at 60 seconds because we use a singleton here. This value here lives as long as our application does, and it doesn't care about if the call actually stopped or not. And of course, we could do something like set the session time back to 0 here. That would work, of course, but there are very many scenarios in real applications that are much more complex than this and where it's not so obvious what kind of states you actually need to reset in which scenarios, because you don't always have this obvious stop timer function. So in these cases, you would need to provide some kind of release function or so that just releases all the dependencies in this stateful singleton, which then again is not obvious that you actually need to call this. Maybe for you it's obvious if you write this code, but if someone actually is new to your team, for example, they won't know that they actually have to call this release function when they navigate out of the call or whatever you're building. So now that you hopefully understood the problem, let's talk about the solution. And the solution is not using the singleton scope here because this dependency is not needed for all screens. Wouldn't it be much better if we could scope this dependency only to these two screens where it's needed? Because then that would mean that as soon as we leave the call, the dependency would be destroyed. And as soon as we start a call, the dependency would be created. And that means if it's created newly, that since this object is just a new object, it will have the default values. So we don't need to worry about previous values, that we need to reset these values, because as soon as we create a new session timer instance, the session time will start at 0 and is running will start at false. So no matter what kind of complex state you have in this object, you can be sure that when you need the object, the state will actually be the default one. So let's talk about in particular how we can achieve this. Usually, when I talk about the minimum required scope, you want to scope your dependencies to a specific view model. And that is luckily very easy with Dagger-Hilt. So we don't want to use singleton here. Actually, we don't even need to specify the scope directly here. We can just go to our app module or create some kind of other module, replace the singleton component with view model component, and replace the singleton scope with a view model scoped. And that would now mean that if you inject this dependency into a view model, then the dependency will live as long as that specific view model's lifecycle is. So if that view model is, for example, bound to a fragment, then that would mean that the dependency lives as long as that fragment is actually on the backstack. Or if the view model is actually bound to an activity, it would live as long as that specific activity is on the backstack. So until the user actually presses the back button and kind of pops that activity or fragment from the backstack. So we would then have something like this session view model I created here, where we just inject such a session timer. And since we provide this here in our app module in view model scope, and we inject it in a view model, this session timer instance will live as long as that specific view model. So as soon as this view model's onCleared function is called, the instance of this session timer will also be destroyed. And when we then go back to the screen where this view model is actually bound to, it will simply create a new session timer instance, which it will then inject into this view model. But if you remember, and we take a look at our navigation graph, we actually need this dependency across two screens. So we kind of need to share it. So between two fragments in this case, how can we do that? So there are actually two ways of doing that. Let's talk about way number one, and that is we can scope the view model to the activity where these screens are actually in. So if you would have some kind of auth activity for login and registration, then the login fragment would be in there. And you could have some kind of video call activity where you put in these two screens, and then you scope the session view model to this video call activity, which hosts these two fragments. And then you can be sure that this dependency, this session timer, actually kind of lives as long as your two fragments in which you need them, or actually lives as long as the application which hosts these fragments. However, that doesn't always work. Very often we actually use something like a single activity architecture, that you just have one single activity in your project, and if you then scope a dependency to that activity, then it's pretty much a singleton, because there is only one activity. Also, if you're using Jetpack Compose like I like to do it, then you also likely only have one single activity, because then you have the set content function, and in that you just put all your code. You use composables. You don't use things like fragments with Jetpack Compose, at least if you're just purely using Jetpack Compose in your project. So how can you do that if you just have one activity, but you still want to be able to scope the dependency, to scope this session view model only to two screens? And the solution is a third way of scoping our view models, and that is scoping it to the navigation graph. Let's talk about that. On the one hand, if we are using XML, then we can use something like a nested navigation graph, which is this one here, actually this, where we just specify the screens that belong together between which we want to share a dependency. So in our case here, in our very simple example, just the video call fragment and the call info fragment. So these two screens belong together. We want to share our session timer between these. And now we want to be able to scope a view model just to these two screens. So as soon as the user leaves that kind of navigation graph here, we want to destroy the view model and its dependencies. What we can then do is here in navigation graph 2, this could be our main navigation graph, for example, where we have our login screen. And then we can use a nested graph. So we can just go here to plus and include such a graph here if you actually have that in your project. And if we use such a nested navigation graph, then we can also scope a view model to the lifetime of this graph. So as long as the user is actually in one of these graphs screens. Let's see how that works in main activity, and I will of course also show you the compose way of doing that. Or actually not in main activity, by the way, since we are using fragments here. Let's open this video call fragment here, which basically belongs to this nested graph here. So we have video call fragment, call info fragment, and we want to go into both these fragments, video call fragment, and we want to say private val view model is of course a session view model, and we say by nav graph view models. And here we simply pass the ID of our navigation graph, which is r.navigation.nested graph. And that way we effectively get this session view model instance that is scoped to this nested graph. So if we actually take this line of code and also put it in our call info fragment, then this fragment and this fragment will get the same instance of the view model, but the login fragment will not get this view model's instance. So that means we effectively scope the view model to our two fragments that are both in the same activity. And since we scope the view model to these two fragments, we also scope these dependencies that are inside the view model to these two fragments, since we simply inject them in the constructor, and that was provided in view model scoped. So that's how that works with XML. Let's take a look how that works with Jetpack Compose. For that, we need to go to main activity. And by the way, before I tell you that, I want to also show you that I actually included dependencies to have this nav graph view models. So these are the dependencies I used. Of course, Dagger-Hilt, navigation component just for the nav graph stuff. And I think from one of these fragments, I assume from the fragment one, you get this nav graph view models dependency, or from this extensions. And here these dependencies are needed for what comes with Compose now. Let's go to main activity and actually have our nav host, and first of all declare nav controller. Remember nav controller. We have our nav host where we pass this nav controller. And instead of the graph, we specify a start destination, which could be anything here, start destination. We open this block of code, and usually you would put in your single screens here as these composable blocks. But since we want to scope a dependency to multiple screens that belong together, we want to also use kind of a nested graph here, which we can do with navigation. So we say navigation. And now this nested graph also has its own start destination, so just the screen that should show up at first when we navigate to this graph, which could be something like nested screen 1. Or let's take our example here. That would be our video call screen. And the route of that would be something like video graph, for example. So that is how we would start to navigate to this graph. And then inside of this graph, we have the start destination of video call screen. So in here, we can now put our composable blocks. This one will get a route. The route will be video screen, a video call screen, I actually called it. And here we get a backstack entry. That is interesting for us because with that backstack entry, we actually get information about the kind of the life cycle of these different screens. And with that backstack entry, we can also scope our view model to this specific graph. If we want to retrieve a view model's instance in Compose and we're using Dagger-Hilt, we do it like this. So we say view model is equal to Hilt view model. And that also comes from a dependency. I will actually just push this to GitHub and you can copy paste the dependencies for your project. We also use session view model and that's it. So that's how we retrieve a view model instance in Compose. What kind of lifecycle will this view model instance now actually have if we just use the function like this? Well, I think if we use it like this, it should be scoped to whatever is the parent of our composable here of the setContent function, which would be the activity in this case. So all the view models would be scoped to the activity. If you're using that in a fragment, it would be scoped to the fragment. But what we actually want to do is we want to use this backstack entry to give it information about a specific lifecycle. So we could pass this backstack entry in here. What this would do is it would simply scope the session view model just to this screen, just to this specific backstack entry. So if you want to scope a view model just to one screen in Jetpack Compose, this is how you would do it. However, we want to scope the view model to 2 screens since we want to share the session timer instance between these 2 screens. How do we do that? Well, we will go ahead and say val parent entry is equal to remember, import remember, and here in parentheses, we say backstack entry. By doing that, by passing backstack entry here, we basically accomplish that whatever we put inside of this remember block will be re-executed whenever backstack entry changes. So in here, we're going to say backstack and actually no, nav controller dot get backstack entry, and we want to now specify a route of the backstack entry we want to get. Which backstack entry do we want to get? Well, we want to get the backstack entry of our nested navigation graph, which in the end is this video graph. So we pass our video graph here, and then, whenever this backstack entry actually changes, we save this parent backstack entry in this variable, which we can now pass here for our view model. We can then copy the screen, paste it, and have our call info screen here. And in the end, that's just the same now. So now these 2 view models will essentially be the same instance. So that's how this stuff would work with Jetpack Compose. I hope that wasn't too complex here. This is definitely a more complex topic, and I hope it got clear why this is really an issue. It's not just about memory, that is one concern, but the main concern I see is that you have these stateful dependencies that you share across your whole application, and then it's often an issue that state doesn't properly get reset. I ran into so many bugs because I did that in my earlier days, so I thought I will share this with you. Of course, if you're using your dependencies outside of a view model, then you can also use different scopes. Very rarely I actually need to directly provide a dependency in a fragment itself or an activity itself. Don't actually know when you would do that, but if you do that, you could use something like a fragment component. What's more likely is that you inject a dependency into a service, for example, then you could use a service component to just scope it to that service. But in most cases, you either use singletons or view model components here. And of course, I don't want to raise the impression that you should never use singletons. That's absolutely not what I'm trying to say here. Use singletons, but only if you really need this single instance across your whole application's lifetime. And especially if the singleton is stateless, like for example, a retrofit instance that doesn't contain some kind of values that can change, then you also eliminated the aspect that you can run into very deadly bugs. But the more you actually need your dependency to be shared across multiple screens, the more you should take care of actually scoping it the right way. So I hope this video helped some of you and actually clarified what I quickly explained in my short a little bit. If so, definitely let me know that down below. And if something's unclear, also let me know that below, and I will hopefully find time to reply to your comments. Apart from that, if you want to see some other specific topics, please also just let me know that in the comments. And if they actually get some upvotes that I can see that many people are actually interested in that, then I will of course make a video about that as well. Thanks so much for watching. Have an amazing rest of the week, and I'll see you back in the next video. Bye bye.